Welcome back. Today we're going to go over 10.2 data distribution. And when we're looking at this one, we have some vocab words to kind of figure out a couple of things. So displaying data, data or data, whatever you want to call it. Data can be displayed or viewed in various graphs, including dot plots, histograms, or box plots. Dot plots are useful for showing centers and variance. So what that means is finding out where the center is and then how different the data looks. So center and variance. Then we have the spread. The variability or the spread in the data describes how far apart the data is from one another. This can be represented by the range. And if you recall the range, to get the range, you take the highest number minus the lowest number, and that'll tell you the range of your data. The smaller that range, the closer they are together, the larger, the further they're apart. Okay, center. We have a median and mean. They both are center of data measurements. And so when the data is skewed, then that means the median is the best representation for the data. If the data is symmetric, then the mean is the best representation of the data. And what that basically entails is the shape of this data. It can take on three different shapes. We have symmetric, we have skewed right, and skewed left. Now, symmetric means that it's following the same pattern here across. And it doesn't have to be identical, but pretty close to where this middle part, it has the same or similar set of numbers on both sides. So it's symmetric. Skewed right, it doesn't seem like this would be skewed right because these points are on the left. But what that means is that from the center, so right here would be around the center, it's moving off to the right. This tail is off on the right. And so that means our data is skewed because it's not symmetrical. We don't have the same number or similar numbers on the left as we do on the right. So because this trails off to the right, we call that skewed right. And same thing for the left. This is skewed left because this tail goes off to the left when the data points are over here on the right. So hopefully that kind of makes a little bit of sense of what I'm trying to explain there. Skewed right and skewed left it's kind of interesting or tricky. So, all right, so using the dot plot, we're going to answer the questions below. At the doctor's office, the pulse of each patient was taken, and then the data is displayed in the dot plot below. So we look here, for every dot, that's a piece of data that was recorded, or a patient. So here there were two people that recorded their pulse at 64, 2 at 66, and so forth. And I could count all of them up and figure out some stuff, but I just need to answer the questions. So if I look at this one, what's the lowest pulse? Well, this right here is the pulse. The lowest is 64. So I would go ahead and say that the lowest is 64 beats per minute. And the next question, what is the highest? I then go to the far right of this, and it says 80. That's a dot above 80, so the highest would be 80 beats per minute. And then what is the most common heart rate? Now that's a different way of asking what's the mode or the most. And in this case, 70 is clearly the most because it's the highest dot plot. So I go ahead and say that 70 beats per minute is the most common heart rate. And then how many people have a pulse over 76? So I have to go to 76. There's a one person at 76, but it says over 76. So I have to go above that. And it looks like there's only one person that has a heart rate higher than 76. So that would be one person. And then how do we describe the general spread of the data? Well, if we look at this one, if this is our center point here, it looks like there's some data points here off to the left. There's some data points here off to the right. And if I were to draw a curve following that, it's a pretty similar spread. So I would call this symmetrical. And that means that the data, it has an evenish distribution of data points on the left and right. And 70 is the most common. Okay, next question. 2. Analyze the data distribution in the dot plots below. Then complete the chart with your findings. So if I look at these two dot plots, the very first thing that I notice is the dot plot A has more points than dot plot B. But going through plot A, where's most of the data located? Well, in this one, most of the data is located between 1 and 2. Like that's where most all of the points are. And then how is it spread out? Well, if we look at the spread of that data, they're all within 6 points of each other. So between this first point here and that end point, they're 6 points away, or 6 numbers away, and that's really close. Like 6 is between 6 numbers. I mean, that's a fairly close spread. And then is the data grouped around the middle, left, or right? Well, if I look at that one and I look at the distribution, you can see that on this side right here, it's going towards the left because there's more points grouped right here, and there's only one on this side right there on the left, but the rest of these are off to the right, so that's almost like a skewed right because that tail's coming off. And then what could this data represent? Now this one, the answers are going to vary. Like it really depends on what you're thinking about. But if I were to just have a random example, this could be the number of smartphones that people have in their home. And if I were to think about that, yeah, there's one person that doesn't have a smartphone. Maybe your grandma doesn't. And then there's a lot of people that only have one smartphone or 2 smartphones. And then there are some people that have 6 smartphones in their home. So like it's a distribution of whatever you want to call it. We could also say, being ridiculous here, we could say that this dot plot represents the number of boxes of cereal people have in their home. Well, there's a person that doesn't have any boxes of cereal, or there's several people that have 1 box of cereal, and there's one family that has 6 boxes of cereal at home. So, I mean, it's just, it could be viewed any different way. Okay? So that's why answers may vary for this information. All right, so if I were to go to the next one, plot B, where is most of the data located? Well, most of the data is located, it looks like, between, I'd say 17 and 24, but the 20 has the greatest number, but it is kind of spread out over a duration, or over a distance, sorry. And then how's the data spread? Well, if I look at that one, 24 and 10, there's a range between 10 and 24. Means that the numbers are all 14 apart, and that's a pretty big distribution. Like if this was test scores, we were not having a ton of students scoring very high. Like it's a very widespread information. And so that there's a lot of variance in this data. Whereas this one, they were all kind of closer together within 6 points, even though it looks like it's spread out and this one's spread out. This one only goes 6 points away, whereas this one is 14 points away. It's over double the distance of their spread with less data points. And then how's the data grouped? Well, it's not grouped. Like 20 is the biggest there, and then it's just kind of all scattered. And then again, the answers will vary for what this data could represent. And this one, I mean, it could be the age of people walking into a supermarket. You just stop and say, "Hey, I'm doing a survey. What's your age?" And this is what you'd get, the age of the individuals. Or, I mean, it could be a lot of different things. If we look at those numbers here, 12 or 10 to 24, maybe it's the number of red cars in a parking lot, or the number of I don't know. There's just lots of different things you could do to describe this, and nothing's coming to my mind at the moment. Yay! You guys love it, I know. But we're describing it, and like we're finding what this data could be. It doesn't necessarily mean what it has to be. Okay. The next one, we're going to analyze the shape of the data distribution in the histograms. And histograms are like bar graphs, but they're unlike bar graphs when they are touching here, because this is sequential data going from 0 to 9 and then 10 to 19. There's no gap in between there, whereas bar charts, they have a gap and they have a set number that they're referencing, or a set thing that they're referencing, and it doesn't go from a range of things. But answering this one, here we have the number of points scored. Oh, excuse me. And then up here we have the frequency that it occurred. So if I look at this one, we have a frequency of 15. So there are 15 points between 0 and 9. And then there's 18 points between 0 or 10 and 19. The frequency, there's 18 of them that occurred. And then on this one, it looks like there's 4 between 20 and 29. So there's 4 values that occurred between that number set. And then there's 1 that was 30 to 39 for the number of points scored. Okay, so if I look at this one, the histogram showing the number of points scored that gave has what type of distribution and where can most of the data be found? Well, if I look at this one specifically, most of the data is right here. I mean, that's a big chunk of data between those first two because that's 15 and 18. I mean, you're looking at 33 of the points, which these ones only have 5. So I would say the majority is between 0 and 19 because that covers both of these ranges here. And it's also skewed right because there's this little tail coming off to the side going to the right. So the data has a little skewed to the right. Now, looking at the pediatric patients here, if I look at this one, it tells me the height in inches. So this is the height of the people in inches. And this one says the number of patients that they put on this data. So it looks like there's 2 people that were between 30 and 35. And their height in inches now, it says pediatric. So that's going to be children because if someone's 30 inches tall, that's really sad because that's very, very short. But yeah, so if we do that, then we have 35 to 40, 40 to 45, 45 to 50, and so forth. If I look at this information, the very first thing, the majority of the data, it's between 45 and 55. And then it's skewed left because there's these little tail coming off to the side here, going to the left. So I would go ahead and say that it's between 45 and 55, and it's skewed left. Man, I got the yawns. Okay, so with that one, that's everything that you'll need to know for today. Sorry it took so long to get this one out, but let me know if you have any questions. Have a great day.